Well, hello there. Welcome to week 2 of Discrete Mathematics, CSCI 26 with Brian Baker. That's me. So I heard from several of you last week, and I absolutely agree. I think that book is probably a little bit obtuse and a little bit hard to read and probably not the best resource for you. I'm going to try and pull in some other resources besides the book, but I said, we're at a point right now where the book is, we haven't gotten very far in. So as opposed to just let's stick with it. Let's make a change now, fix it so that it's better for the rest of the semester. I've got no problems admitting that I chose a book because it was on an ACM recommended list and, probably should have stuck with my first choice that maybe doesn't have a couple things in it, but they're not in the Title V anyway, and I don't know the course outline or record anyway, and I don't know that we're going to have time to get to them anyway. So let's just choose the book that's a lot more accessible. So there are some changes, at least 3 changes that are going on right now for the class. The first one is it's a new book. The new book is in the syllabus. It is in the exact same location. So you can still go to Safari. I keep wanting to use the old name, Safari Textbooks Online. It's now called O'Reilly Higher Education. You can go to O'Reilly Higher Education, just look up Discrete Mathematics Hunter. That'll pull up the right book. And then once it's in your history, it'll be there for the rest of the semester, so you don't have to worry about it. The book's a lot more accessible, a lot more readable. And I think it's going to track a lot better for people. There's also going to be some more lab resources. I think I'm going to sort of adopt, I'd say a book. It is a book. You can buy it in hardcover if you wanted to, but it is far more popular as a website. Automate the boring stuff. It's a great sort of tutorial for Python. If you were to consider going on past this course and past the stuff that we're going to do, it'll actually teach you a lot of really practical stuff. I use it for another class at Oregon State. We're pulling down JSON data from the web, from the CDC, and parsing this huge amount of data and, pulling up sort of insights and stuff because you can process stuff however you want. But point being, what we need it for is to sort of learn the basics of Python so that we can get into some of the finite math stuff that we care about. And maybe we'll do a little bit of sort of data science stuff. But for us primarily, it's going to be, let's get the basics so that we can do stuff like set operations and functional programming and the sort of stuff that we're going to talk about in this class. Maybe even the representation of graphs, although very few languages have graph where it's built in. Python doesn't, but we have a way we can represent graphs with objects. So anyway, and hopefully this feels a lot easier. You've all taken CSCI 40 before, so learning your second language is a lot easier. You don't need to know what a variable is. You don't need to know what a function is. You've already got that. If you feel a little iffy on those things, well, all right. When you do it in the second language, that sometimes now it clicks, right? That second time through, now I get what I'm doing. So hopefully that's the case for you if you don't already feel confident in sort of basic programming stuff. So new lab resources, new textbook for the thing, and I'll be throwing in other resources as well as I can find them. The other thing we're going to do is I'm going to stagger my schedule by moving our weeks slightly. So I'm going to give you an extra day sort of this week. Which is good since this is coming up at the very end of Tuesday as opposed to the morning. And so our weeks are actually going to begin on Wednesday and end on Tuesday night. So all of your assignments will be due Tuesday night. That may not make the most sense in the world, but just because this semester I've got so many video assets I have to create for so many classes, it's really annoying. And so I would like to go to bed before 3 a.m. sometime this week. So what I'm suggesting that we do is by staggering it, then it's okay, so I don't have to have everything done on Monday. I can sort of spread it out. Of course, I can bleed into Sunday, and then I've got other classes that'll be later on. So anyway, so our weeks are sort of shifting just one day. They'll start on Wednesday, end on Tuesday. Your assignments will be due Tuesday night. You'll still have a full weekend to do stuff. There we go. So what are we doing this week? This week, reading chapter 1.1, so section 1.1 of the new textbook, not the old textbook. There's going to be some overlap, probably a good amount of overlap, but that's all right. We're just sort of setting stuff up for the new book. There's stuff in that section that's not covered in the other book, so it's just hey, a little bit of repeat is fine, especially if you didn't really understand it from the last book. And so then there's also a lecture that's already up, and that should be set to go. It's where I kind of walk you through everything. We do some stuff that's a little bit more complicated in this one, so but hopefully it still feels more natural. I also have a new way of doing lectures, so hopefully you like it a little bit better. We'll see. Lab book chapter 1, peruse it. You already know a lot of those concepts, so you don't need to learn it for concepts. You're just learning to sort of get the syntax in Python. And the fact that Python doesn't require you to even create a function, like we will eventually, but you don't have to. You can just start by scripting lines of code. Makes it a lot easier. Your joke thing could have been one line of code. Print, open paren, quote, your joke, end quote, end paren, done. One line of Python. If you didn't realize that, go ahead and go back in there and do it. Anything from week 1, I'm going to accept late because, this was sort of obviously it was a last minute thing. So anyway, that's all fine and good. Glad to be here for everybody. So lab book chapter 1, done. And then there should be a demo for Python for those concepts. We're going to be talking about variables, operators, expressions. Python has just a few different operators like star for exponents, and there's a // for different things. But we'll talk about that then. So different operators to create sort of expressions. We'll talk about the input command, which will allow you to get input from the user, but that requires us to have to learn how to convert one type to another. Even though Python is not a typed language, it is super loosey-goosey. You're going to find Python to be a lot easier than C++ if you just got out of CSCI 40. But it does mean that we still have to convert stuff, like input grabs stuff as a string. If you want to do numeric operations on it, you've got to convert it to a floating point number somehow, or to an integer or whatever. And it's super easy. It actually looks almost exactly like a C-style cast, but you're sending it to a function that just happens to have the name of the type. I'll tell you how to do it in the demo video. Expect that up soon. I'm actually probably going to prioritize your class because your class has had sort of the rougher start than my C++ class or anything. So I'll delay their demo. They'll be fine. Plus their lecture actually much more aligns with their demo. So anyway, so then as for graded assignments, what's going to be happening this week? Number 1, quiz number 2. It is going to be partly repetitive because the material was partly repetitive, but I am kind of pushing it a little bit more. Hopefully you feel comfortable with it. There's going to be some sort of stuff about understanding truth tables and how that works, and sort of larger, kind of more complex, propositions that are sort of made up of these conjunctives and sort of creating them to create larger propositions. That's part of the lecture. It'll be a part of the quiz as well. Remember, you get 2 shots at it, so just kind of study up ahead of beforehand and should be fine. Discussion this week is meant to be fun. Don't take it too seriously. We're talking about propositional logic. There is sort of I think it's kind of a famous thing, but don't look this up online. It comes from a movie. But if you know the movie, then you just have great taste, and I guess you can solve the problem pretty easily. But regardless, it's called the riddle of doors. And so the idea here is you're not going to see anybody else's post until you post. So the idea is you put forth your sort of best effort. Doesn't have to be right. You're not graded on being right. You're graded on participating. So put forth your thoughts of hey, this is how I think we could solve this. This is how I think we could ensure we're choosing the right door. Based on, my thoughts, and maybe you drew a little truth table or something. Great. And then work together as a class. You don't have to reply to different people. If there's one thread that's really popular, just stick with that. If that's where the conversation is because people thought, oh, hey, I think that's the best path to go. Just continue on with that conversation and try to together solve the problem so that you don't lead to certain death. That is the riddle of doors. It comes from something. Next week, I will probably just give you the YouTube clip from the movie it comes from, which will have your solution. The other thing is lab number 2. This is just going to be using some basic expressions to do a little something. It's also kind of morbid. Boy, the riddle of doors, avoiding certain death, and then your lab is called time of death. So forensic scientists will often use body temperature as a way of determining when a creature deceased. Could be a human being, could be an animal, who knows. But the idea here is that I want you to be able to input the temperature of a body at the time of death, and based on just Newton's laws, determine what the temperature of that body would be 1 hour after, 2 hours after, 3 hours after, and 4 hours after, and then just print those values. A lot of that math has been done for you. I sort of leave like 3 and 4 hours after, but if you can pattern match, you're going to be able to do it easy. I don't want the labs to be hard because you've got a lot more going on in the class than just the labs. But it's just a way to sort of supplement, and we need to sort of get you through the basics of the language so that we can begin doing those discrete math things. If I ever screw that up, it's because my department has a class called finite math and discrete math are really just English-wise similar. So anyway, they are completely different concepts. But anyway, I'm just going to float it up a lot because I say finite math a lot more than I say discrete math in my life. By the way, real forensic scientists don't go forward, they go backwards because clothes, all sorts of things, body weight, they can make a difference to the way a body loses temperature over time. So they generally will monitor the temperature decline, plot it on a graph, and then project backwards using Newton's laws, but then giving them sort of a buffer. That's a lot harder. We're going to go the easier forward route. So I always get a little chart of where you would expect that thing to be. Maybe morbid, maybe interesting. You'll either think that I'm fun or a horrible human being. One of the two. I don't know. But if you have any questions, be sure to send me a message on Canvas, and I will see you online.